So my name is Goodman-Wilson. I'm on the developer relations team at Slack. Prior to that, I was a philosopher. And I like to think a lot about the philosophy of mind and the structure of minds. I want to start by thinking about, is the timer not working? This is going to work to my advantage. I want to start thinking about chatbot psychology. I want to think about the structure of the bots, and in particular, I want to think about the kinds of structures that give rise to intelligent seeming, or actually intelligent behavior, because that's sort of the end goal of a chatbot in many ways. And I want to do this, it is going to auto-advance, by thinking about Roomba. So Roomba is an amazing thing. It's this little robot, it vacuums up your room. Doesn't matter what shape or size it is, doesn't matter what's on the floor, it'll navigate around all of these things quite dynamically, and it's really good at it. And you might think that it's doing this by carefully planning out everything, by developing an internal representation of the room as it travels through it, and manipulating that representation to figure out where it needs to go next. But in fact, you'd be wrong if you thought that. It's dumb as dirt. As dumb as the dirt it vacuums up. It operates on a set of basic stimulus response mappings, and it doesn't form any sort of internal representation about the room that it's in, or reason in any way about the room that it's in. It operates on 4 rules. First of all, the first most basic rule is travel straight forward. That's easy enough. The second rule is if the the second rule is if the bumper gets bumped, then turn. The third rule is if the dirt sensor goes off, then move in a spiral. And then the final rule is if the cliff sensor goes off, back up and turn around. And these 4 rules are arranged hierarchically so that the more important ones override the less important ones and thus keep the robot from committing suicide. But the end result of this is intelligent, complex behavior, right? So here's a map of Roomba having cleaned a room. It does quite a good job of reaching everything that it can reach and vacuuming it all up. And it comes simply from mapping inputs to outputs, very simple maps from a stimulus to response, and then arranging these mappings in a hierarchical way. So let's take a trip back through time to the 1960s. A little history of ideas here. The prevailing AI theory at the time said that to get interesting, intelligent behavior, complex behavior, you had to be doing symbol manipulation, right? You had to form external representations of the world. The culmination of this was this great little bot called Sherdlu, the forerunner to every text adventure game you've ever played. And you could manipulate, or ask it to manipulate blocks in block world, different sizes and colors with these simple text prompts. And it was awesome until you tried to expand it outside of the toy universe that it worked in, and then everything just sort of went to shit. And so the thought was, well, this isn't going to get us anywhere very fast. What are we to do? So Rodney Brooks at the AI lab at MIT thought, well, let's turn to behaviorism, right? So behaviorism is a theory in psychology that human behavior arises from stimulus-response pairings arranged hierarchically. And he thought, what if we could turn this into a robot? Could we make robots act like humans? And he called this subsumption architecture. And he used it to build quite a number of successful robots, both in the lab and commercially, of which Roomba is one, but not the only one that he's built on this model. But the point is, there have been a number of very successful robots built on this that all do the same thing. They map inputs, outputs, stimulus to response, and organize them hierarchically. Breathing. So what does this have to do with chatbots? So it turns out it has a lot to do with chatbots, because chatbots are things that exhibit intelligent or complex behavior. So here's a couple of chatbots that I wrote. They engage in conversation to heckle somebody in your Slack team. And it looks pretty cool when it happens, but it's actually very straightforward. And the point that I want to make about this is that it's not hard to get started with bots, right? You don't have to engage in massive amounts of deep learning, because complexity does not, well, you can get complexity from complexity, but you don't have to. So just to make my point, there are 3 elements in this image, but you're already forming a story about what's going on in here, right? In your head, you're wondering, why in the hell is this slide up here? What is this flood? There's no flood, there's just 3 things over there, right? Simplicity can beget complexity, right? By mapping inputs to outputs, mapping stimulus to response, arranging them hierarchically, you can achieve an amazing amount of very interesting, very intelligent seeming, very complex behavior without resorting to more complex mechanisms. So that's what I had. Thank you very much for your time.